Welcome to Between the Vines. My name is Kevin Martin. I'm here with Jennifer Phillips Russo. As promised last week, we are going to continue to talk about soils and get started a little bit into looking at soil tests and what might appear on your soil test, why it might be there, and what it means. And we're going to talk about cation exchange capacity today. And Jennifer is going to kick it off, and I'll try to play the farmer who might have questions. We didn't get too many questions from growers, so I will do my best to fill in that role. Jen?
Thanks, Kevin. So last week we talked about, how to soil sample. And now I want to talk about when you get your soil sample results, some of the information that you get on there and how you can decipher it and what it means for you. And one of those that I hear a lot of things about that people don't quite understand, and it's okay because it is a very confusing concept, is CEC. So like Kevin said, that's cation exchange capacity. And in order to know what that is, I think you need to know what cations are and why it's important. So let's back up just a little bit. I want to give a little bit of differentiation between soil health. Some people call it soil fertility or chemical. It's the chemical part of a soil test that you get out, and that is your nutrients. That's the fertility. Just that, when we're looking at just the nutrients or the chemical portion, because they have charges to them, whether they're going to be negative or positive, that is what our normal soil health tests come back with. I'm sorry, I just said it and I used them interchangeably and we shouldn't have. It's not soil health, that is soil fertility. When we're just looking at the nutrients in the soil, that is soil fertility. Soil health is when we are looking at the aggregate stability and the penetration, like the ground penetration for compaction, the living biota that's in the soil, the microbes, that's all soil health. We're going to talk today a little bit about soil fertility. And in saying so, I want to try to break down what CEC is without using a lot of scientist words. Basically, your soil has particles in it. Those particles are minerals. They're going to be, well, there's also organic matter. So they're made up of minerals that are composed of either sand, silt or clay particles, and organic matter. Most of that has what's called a negative charge to it. And we're going to talk about that in depth a little bit more, but I want you to remember just the soil is the negative charge to it. It is the nutrients or nutritious chemicals that the plant wants that has a positive charge to it. And we know negative and positives attract. And that's where this cation exchange capacity comes in, because different particles in your soil have different negative charges to them. Sandy soils are bigger particles, and you'd think that they would have more negative charge to it. But clay particles have the most negative charge to it because there's a lot more surface area on clay than there is in a grain of sand in the soil. Is that okay so far? Am I getting too far into the weeds? Am I getting too, Kevin, you're my farmer? Are you confused yet?
Yeah, no.
Okay.
I'm okay, I think.
Now, not all soils are the same, and we all know that in our own blocks. You have different soil right within your vineyard blocks. So some have more sand, others have more clay, but each one in its unique blend actually determines its color, its texture, and its storage capacity for nutrients, or those nutritious chemicals, which is why we get the chemical portion on our soil tests when we get them back. That's what's going to tell you all the nutrients in your soil. Okay. So I need to check my notes. I want to make sure I have it all set down. I don't want to go too fast. I don't want to go too slow for you. I was just talking about how sand is larger and you'd think that it would have more holding capacity. If you had the same amount of sand in, let's just say, a box is the same amount of clay, you will have 1,000 more times of the nutrient holding capacity in clay than you would in sand, even though it's the same amount in there in a volume. So clay has a really high CEC, or cation exchange capacity, because of all of the surface area on those thin sheets. And sand has a lower CEC. that is also meaning they're negative. We want to attract yummy nutrient chemicals, which are positive. Clay can attract more than sand can. Is that helping so far?
Yeah. So the only thing I would say is I think it's important to add some context to what the soils look like in our region. Because especially since this is a podcast, you definitely we don't screen IP addresses. You can listen to this whether you're in the Lake Erie region or not. Um, so we've got some glacier stuff, glacial action things happening here, but we have some very our soil is in a group. Like we have some distinct patterns of what CEC looks like in our region. Um, we don't grow anything on pure sand. I don't know very many people that do, especially without irrigation. And we're dry farming over here, so nothing is pure sand. A lot of people like to talk about the gravel that we have, and definitely nothing is pure gravel either, where we're growing grapes. So do you want to comment on that? I don't want to draw any conclusions, but maybe I'll add some.
Yes. Well, that's kind of jumping forward a little bit. I will talk about that and comment on it right now because you asked. So the Cornell Soil Health Department has some fact sheets out there, and this is basically for New York State. And common CEC ranges in New York, there's 5 on this table that they have here. And one is the fine textured soils that developed from clayey lake sediments, medium to fine textured soils, and they're developed all from lake sediments. So you're going to find them probably closer down by the lake. And they usually have a CEC of around 25. They range all the way down to a more coarse and very coarse textured soil formed from the gravelly or sandy glacial outwash from the lake bench, beach ridges. And those are going to tend to be around 12 CEC. So the range in New York State and the common, I'm not to say that you're not going to find some higher, you're not going to find some lower, usually range somewhere in between 12 and 25 CECs, depending on the more heavier soils are going to have the higher CEC, and the more sandier soils, gravelly soils will have a lower CEC.
Okay.
That help you? Did that answer your question?
It did. I do want to provide some, I guess I'll call it farmer context, if that helps. So, if you talk to farmers across the US, what's that?
Don't talk about implications, because that's what I'm going to.
Oh, no. If you talk to farmers across the US, you'll find regions where anything less than 20 or 25 is considered a light soil. And you can see here, at least according to the fact sheets that were being referenced, that 25 is about as heavy of a soil as we get, the highest CEC that we have to deal with in our region. And I think on the high end, that really captures what's happening here. I very rarely see anything over 25. And if I did, it's like, it's a 10-acre block with a quarter of an acre of a high CEC, or maybe a few acres, but nothing more than that.
Too.
What's that?
And probably poor drainage too in that super high CEC.
Possibly, yeah. And the only thing I would say though is, when you look at sort of the lower CECs that they contemplate, we definitely see lower CECs than what they are contemplating. So I actually grew up on a farm that I was told, had very heavy soils. That was the understanding of, the owner operator, my grandfather at the time. Like that was his understanding. The nice gravel bench on Route 20 was where you wanted to grow grapes. But his ancestors had purchased land that was closer to town and had heavier soil because transportation was the big deal in the 1800s, not growing grapes in the mid 1800s. So, the average CEC from that land is 10. That heavy soil is 10. So it's not heavy at all in the context of how people farm across the US. And it's not really even all that heavy compared to the rest of the region.
Oh, it's lighter than compared to the.
Right. And, you look at where they expanded that farm over the years, and it's around 8. So he was obviously looking for lighter soils, found some. and they are lighter. But in the context of reading a soil sample, we look at across the US of CECs between, I don't know, maybe 3 or 4 and 50. And in our region, everything is between 5, almost everything's between 5 and 20. And, we see huge differences or talk about huge differences where there's just a very small difference in CEC. So that's sort of that farmer experience that, when you're talking to a soil scientist who doesn't farm 100 acres, they look at data from thousands of different places. Your version of what CEC looks like could be a lot narrower than what they're talking about. You're talking about heavy soils and light soils, and they're going to say those are all about the same.
Yes. Sorry. I'm trying to multitask because I have another meeting at 1:00, and this is being before 1:00. So I just want to let you know I might be a little bit late. Let me just tell you why this is important in regards, because this was one of those things that clicks for me. Once you learn it, you're like, oh, well, that's why that happens. And that's why we talk about this. And that's why we talk about that. I want to read through how I set up this story for you. That I told you about the clay can hold on. They have more negative, they can hold more positive nutrients to it. But what happens with there is a nutrient that's just sitting there unattached, and there are reasons that it can be unattached. That nutrient just basically leaches out with rain or irrigation. So if you want to get a little bit of idea of how these nutrients work and attach onto these soil particles and how you can get them to untouch and get into your plant, I know you've all done this when you were little. And Kevin, I think you were just telling me you did it last week. You take a balloon and you rub it against your head. I wish you could see the mortified look on Kevin's face.
No, I definitely didn't tell you that.
Stick it against the wall and it sticks there. And that's that electrostatic energy that sticks the balloon to the wall. But that balloon is not going to stick there forever. Eventually, it's going to lose that electrostatic and it's going to fall off. That's a similar thing what happens with nutrients and our particles. And when I'm going to continue this conversation, particles are the soil particles, either clay, sand, silt that we've talked about earlier. I'm just going to call them particles. And then I'm going to try cations and anions as going to be the nutrients. Anion is a negatively charged, it's hard to interchange words. I almost said particles. It's a negatively charged ion or nutrient that's out there. A cation is a positively charged. And there's really 5 main ones, but the ones we're most concerned about are potassium, magnesium, and calcium. Those are the 3 biggies that we really kind of look at. Other ones being hydrogen and sodium. Yeah. Sorry, left me for a second. So they hang on to these negatively charged, and the smaller they are with the more positive charge. I know you've seen it on going back to high school on your chemical periodic table. There's a +2, +3, +1. If it's a +3, it's going to hold on to that negative charge even harder than a +1. So that means that certain chemicals are going to exchange faster than others. This is why it's important. So potassium is a +1. So it's going to go a lot faster than you're going to have. I'm getting all crazy because I'm staring at your face and not at my notes and talking just from. So is more than magnesium or calcium. Okay, so I already went over all of that. Basically, if a plant wants a nutritious cation, or if it wants one of those positively charged nutrients that are out there, it has to exchange something. So in order to get it to let go of that negatively charged particle in your sand, you have to, and it can only exchange like a one-on-one basis. So if it wants a potassium, the plant will give hydrogen. It'll let go of one of its hydrogens out into the soil, which is important because we'll learn it not today, but in another soil thing coming up. The more hydrogens you have, that's what the whole pH balance is off of, it's hydrogens. So if you have a lot of hydrogens or positive charge, you've had acidic soil, and less, you have more basic soil. Neutral is 7. So if there's, which is what we'll get into when we talk about base saturation next week, is what I'm planning on doing, you'll get a little bit better understanding of that.
Yeah, so I wanted to just sort of draw attention, since what we're really talking about eventually is soil test results. So on a typical soil test, you'll see calcium, magnesium, potassium. You might see sodium in certain areas. That's a big deal. It's not around us. And the fifth one that you mentioned is hydrogen. So you won't see hydrogen, but in a way you will, right?
Yes.
You want to touch on? So how would I see hydrogen?
That's what I was just talking about with your pH.
Right. So that pH will directly reflect what's going on with hydrogen in your soil.
Your pH is really low on your soil test. You have a lot of hydrogens out there.
Okay. Yeah, I just wanted to you were connecting the dot. I just wanted to
make a cleaner line.
Emphasize the dot that it's almost like a measurement, an indirect measurement of hydrogen.
So this was an analogy that I'd heard growing up, and I thought, that is sort of a little nugget that people can hold on to. The cation exchange capacity, you could think about it as like cups that you get at like a fast food restaurant. You can get either, or a cone at a ice cream. You can either get a kiddie cone or you can get the large mega gulp. And depending on like the super size, pouring nutrients into a soil that has a kiddie cup CEC will only overflow and things will leach out. Pouring nutrients in a mega size cup, it can hold more, so they're not going to leach out. That doesn't mean to say that you can't get the amount of nutrients you need in a low CEC soil. You just might have to do it in split applications or over time. And you can change your CEC, even though it might not change a lot, but organic matter adds to CEC. So for people who have really sandier soils, putting more organic matter into it could help you improve your CEC and nutrient holding capacity. Does that make sense? We're talking like sand is a kiddie cup and clay is a mega cup. Okay. What are your implications? And I'm not trying to speed through this, but I don't also want to throw a whole bunch of stuff that just sounds crazy science at you. The higher the CEC, the more clay or organic matter is present in your soil. And it usually means that high CEC soils have a greater water holding capacity. And you all know that if you have heavy clay soil, most likely you have tile lines. Low CEC soils are more likely to develop potassium or magnesium and other cation deficiencies. But while CEC soils are less susceptible to leaching losses of these cations. Does that make sense?
I'm sorry, what was less susceptible?
High CEC soils are less. Did I not say that? Sorry.
I think you did. The audio might have cut out a little bit.
Okay. So for sandy soils, a large one-time addition of these cations or nutrients like potassium could lead to that leaching. That's why CEC is important, and I need you to understand your CEC. But lower CECs, the faster the soil pH will decrease with time, because the hydrogens have nothing to attach to, not as many as they do. So you tend to decrease in your pH over time with the lower CECs as well. The higher the CEC, the larger the quantity of lime that might be added to increase the soil pH. So sandy soils need less lime than clay soils to increase the pH to desired levels. I hope that gives you a little bit better understanding of CEC and why it's important to what you're going to do to amend your soil fertility.
Yeah, the one thing I would say is your experience in farming might be different than that conclusion a little bit, because if you need more lime because you have a heavier soil to change your pH, eventually you're changing subsoil pH and you're not measuring it. So it takes a whole lot of lime in a heavy clay soil to change the pH, and then that pH tends to fall because the lime moves down in the soil over time. And so if you have low subsoil pH, it might feel like, even though you have a heavy soil, that your pH is constantly evolving or decreasing in a way that you wouldn't expect, because, hey, it's a heavy clay, I should put a whole bunch on and it should be better. That's not always what happens, but you might miss that depending on what your resources are, because in a tillage situation, that's not a dramatic thing that affects your production. But since we do no-till, we know everybody's just putting lime on top. And so it's very difficult to get it to move down into the soil. And to get a lot to move down in the soil might take a decade. And so if you know what your subsoil pH is in a heavy clay soil, you might know where it's going to go in the future.
Well, that was our little bit of discussion on CEC.
All right. So probably logically, our next session on reading your soil sample will include liming recommendations. CEC is one way, of course, since it's a measure of hydrogen, as Jen mentioned, to try to understand exactly how much lime you should put down. It's not necessarily the way everybody uses now, and that's just sort of our teaser for next week. But it is one way that it can be done, and it sort of indicates what lime is required. But there are other ways to do that I think soil scientists have decided are better now. But that doesn't mean you don't need to understand CEC, because it affects sort of all of your other nutrients and what those recommendations should look like as well. Thank you for joining us this week. We'll be back next week. I'll kick it back to Jen to see if there's any last comments she wants to add since I did. And other than that, we will see you next week.
No, there really isn't anything else I wanted to add to that particular thing. But if there is something you're not understanding and there is something that you want us to really focus on before we go, next week is planned for liming and pH, touching on base saturation as well, because it has to do also with those positive, negative charges. But please leave a comment below, email one of us, and we can certainly address those concerns. This is not all going to be soil based. There's also going to be some business management stuff put in there. We're not going to commandeer and just have soil science for the next 4 weeks, 5 weeks, but I think it's
yeah. And we could do that right now. Now that you bring it up, one thing that's going on that's really interesting right now is there are some real questions about what the best CEC is. If you were buying a farm. So I think I mentioned earlier, historically, I grew up on a farm where they said, the CECs are too heavy, the soils are too wet, it's too hard to change things in the soil, and it would be nice to just have gravel. And now that we're seeing differences over the last 5 to 10 years in rainfall patterns, and we're also seeing differences in the way people manage their farms, there have been, some discussions about the value of heavier soils in commercial juice grape farming, not necessarily wine grapes, especially in dryland farming, because you have the potential to have more resiliency in drought-like situations, which were very, drought-like situations used to be very unusual. And, I don't know that we can draw any conclusions yet. I think that, there are a lot of farmers thinking about that. So if you're not one of them, maybe you should start. It's certainly, something worth a discussion to think about. I don't think we can do much more than that, because I don't know if this was a 10-year thing where we get more drought stress, or if it was a 100-year thing, like who knows? So it's definitely been something that has gotten some of the farmers talking, as some of the gravel sites had years where they did underperform in the last 10 years. And there's sometimes more risk there if you're paying, an extreme premium for that lighter soil, and then you're dealing with drought stress, which lowers your yields. So I don't know where that's going to go, but it definitely has the potential to impact farm values, and it has in the past. CEC has always correlated pretty well with farm values. It's just which direction is it going to correlate with? What's that?
How do you combat drought stress?
You can change your CEC eventually,
or add irrigation.
We're not really in a good region for irrigation for a couple of reasons. Like, the investment in irrigation is undermined by the fact that you'll have 3 or 4 years in a row where you don't need it at all. So then you have all that infrastructure out there that's wearing out and, potentially in the sun, depending on what it is. and you're not using it at all. So that's not good. The other thing is, for a lot of our acreage, they don't have access to reliable water. So they have plenty of water to irrigate when they don't need to irrigate. And then when they do need to irrigate, that subsurface or surface water that they have access to, it goes away. They use it up. So if you're not in that situation, if you're in a situation where you know you have extremely light soil and you're betting that droughts are going to become more frequent and you have access to a lot of inexpensive water, then irrigation can really help you manipulate vine size and sort of change the economics for you.
So I just want to throw some other things out there just for people to think about. I mean, this is why we're here, why we develop research projects, why we are trying to find best ways for our growers in this region, knowing that most of you are non-irrigated commercial growers.
Right. But yeah, it does go back to, to speaking to those farm values. If I had a farm 30 years ago that had access to irrigation that was super reliable, just access to water, that really would not have impacted the farm value at all. I don't know if it is now, but it could in the future.
There's mulching, there's roll crimping cover crops. There's a whole bunch of things that we can start implementing.
Yes, we definitely need to have a conversation in the future about water conservation and how you conserve the water that is sort of given to you naturally. The old way of doing it was Roundup, and Roundup was good enough, but are there better ways? And is Roundup going to be around? But I think that's definitely a conversation we're weeks away from as we work through this soil test stuff, but probably relates to soil health. So we'll be in touch with all that information in the future.
Well,
thanks for joining us. We'll see you next week.
Bye, everyone.